Okay, in this module we shall introduce two new connectives. We shall introduce the conjunction, which is known as the AND connective, and we shall introduce the disjunction, which is known as the OR connective, and we shall construct the truth tables for these two connectives. In the last module we had introduced the concept of a logical connective. A logical connective is a word or a group of words that is used to join two or more statements into one bigger statement, which is called a compound statement. We saw a few examples of connectives. Some of the examples were AND, OR, if then, and if and only if. In this module we shall focus our entire attention on the disjunction. Disjunction refers to the logical connective OR. The symbol for disjunction is this V. So V refers to disjunction. Again, disjunction is also OR. So V refers to OR. So as we already established last time, disjunction refers to connecting two propositions by using the connecting word OR. So definition is, if P and Q are two statements, then the disjunction of PQ is the statement P or Q. As you can see here, the statements P and Q are joined together by using the connecting word OR. And this statement is written symbolically as PVQ. So this symbol V refers to OR. Let's take a few examples. The first example we have, P is the statement Tim likes to run. Q is the statement Tim likes to swim. The statement P or Q is the statement Tim likes to run or Tim likes to swim. Another example, we are given the statement, we are asked to find the disjunction of the following two statements. The statement P is today is a Sunday. The statement Q is today is a work day. The statement P or Q is the statement today is a Sunday or today is a work day. We shall now construct the truth table for the logical connective OR. And truth tables are a very important part of this unit. So we'll take an example. We have the statement P, John has a bat. The statement Q is John has a ball. The statement P or Q is the statement John has a bat or John has a ball. Now notice that the truth value of the statement P or Q depends on the truth value of the statement P and the truth value of the statement Q. In other words, whether or not P or Q is true depends on whether or not P is true and whether or not Q is true. Alright, so the truth values of P and Q will determine the truth values of the statement P or Q. So in the truth table we shall construct all the possible true and false combinations of PQ and we shall calculate the truth value of P or Q. Okay, so in the first column we shall write the truth values of P. In the second column we shall write the truth values of Q. In the last column we shall write the resulting truth value of P or Q. So we'll write all the possible true-false combinations. So P can be true, Q is true, P can be true, Q can be false, P can be false, Q can be true, or P is false, Q is false. There are only 4 different true-false combinations for P and Q. One shortcut to write this is, and we shall follow this for every single truth table, is when populating the column for P, we shall fill this column as true, true, false, false. So we shall populate the P column as true, true, false, false. For the Q column, we shall alternate. So it's going to be true, false, true, false. So again, for the P column, we shall go true, true, false, false. For the Q column, we shall go true, false, true, false. Okay. Now notice that the statement P or Q states that John has a bat or John has a ball. That means John needs to either have a bat or he needs to have a ball. That means at least one of these two statements has to be true. That means John either needs to have a bat or John needs to have a ball, but he needs to have at least one of the two. So we can say that the statement P or Q is true if at least one of P or Q is true. That means either P has to be true or Q has to be true, but at least one of them has to be true. Notice if both of them are false, that means John does not have a bat and John does not have a ball, then the statement John has a bat or John has a ball is false because he does not have a bat and he does not have a ball, so this statement is false. So if both P and Q are false, then the statement P or Q will be false. So now in this case, let's see, P is true, Q is true, and we require at least one to be true, so this is obviously true. Second case, P is true, Q is false. We require at least one to be true and we already have P to be true, so this is true. This case we have P is false, Q is true, again at least one should be true and Q is true, so this is true. In the last one, P is false and Q is false, so both of them are false, and as we have said before, if both are false then the statement P or Q will be false. So again, to recap, the statement P or Q is true if, only if, at least one of the two statements P or Q has to be true.